Here we're given the reaction of aluminum with iron 3 oxide, commonly known as rust, to give aluminum oxide and iron solid. And when you do this reaction, it releases 852 kilojoules of energy. I say releases because it's negative 852 kilojoules. This is actually the reaction of thermite, which you may have heard of. Thermite can burn holes through solid iron. It's used in military applications to disable tanks, among other things. So this is an extremely energetic reaction. You may not have known that it's made from aluminum metal and rust. Anyway, this is the reaction, and this is the enthalpy. What's really important to remember when you're talking about enthalpies of reactions is for the reaction as written. If you react 2 moles of aluminum with 1 mole of rust, you will end up with 852 kilojoules of energy being released. Again, released because it's negative. If you react 4 moles of aluminum with 2 moles of rust, you'll get double this. 6 moles with 3 moles, you'll get triple this. The amount matters. From a common sense perspective, this makes sense. If you use a little bit of aluminum and a little bit of rust, you get a little bit of energy. If you use a lot of aluminum and a lot of rust, you get a lot of energy. So again, iron 3 oxide is sometimes referred to as rust. So let's look at these different manipulations. And we want to know the enthalpy of these processes. First of all, in the first case, we notice that the reactants have become products. So when the reactants become products, the sign changes. Instead of 852 kilojoules being released, 852 kilojoules must be consumed. So it's going to be positive, or just 852 kilojoules. However, we've also doubled the amount. 4 aluminums, 2 iron 3 oxides yields 2 aluminum oxides and 4 irons. So we've doubled it. We've reversed it, so we made it positive instead of negative, and we've doubled it, so we multiply by 2, and we get 1704 kilojoules. In the next case, we have the aluminum becoming a product. So in this case, aluminum is a reactant, here it's a product, but there's still 2 aluminums and 1 iron 3 oxide, again sometimes referred to as rust. So we have 2 and 1, which are the same numbers, but we have made them from reactants to products. So again, we have to reverse this, but in this case we don't have to multiply by 2, so it's just 852 kilojoules. In the last case, we have the reactants as the reactants, so aluminum and iron 3 oxide, aluminum and iron 3 oxide, so it's negative 852 kilojoules. However, instead of 2 aluminums and 1 iron 3 oxide, we have 6 aluminums and 3 iron 3 oxides, so essentially we've multiplied this by 3. If we react 3 times as much of each reactant, it makes perfect sense that 3 times as much energy will be released. So we multiply this by 3, and when you do that, you get negative 2556 kilojoules. So the most important thing to remember is that the enthalpy of any reaction is for the reaction as written, with the stoichiometric coefficients in the balanced chemical equation as written. The second thing to remember is that if reactants become products, then the sign changes. Said another way, if you make this reaction go in this direction, instead of releasing 852 kilojoules, you have to put in 852 kilojoules because this number becomes positive. Negative means released, and positive means need to be added or consumed.